find the arc length of the graph of, and we have this implicitly defined equation. We've got y minus 1 quantity cubed is equal to x squared on the interval, closed interval from 0 to 8. Okay, so we know that from our distance formula, we need a derivative. And rather than finding the derivative of this thing implicitly, we need this thing to be a function of x, right? Because we have the derivative, f prime of x, inside of there. So let's take our function, well, not a function, our implicitly defined function, and then on this closed interval, let's see if we can get an explicitly defined equation. If not, then we may have to switch strategies here. So I've got y minus 1 cubed is equal to x squared. Take the cube root, minus 1 is equal to x to the 2/3, and then add our 1 over, and we have 1 plus x to the 2/3. Okay, so we are in business. Now we need to take the derivative of this thing. Y prime is equal to, taking the derivative of that 1's going to disappear. 2/3 x to the, subtract 1 from that will be negative 1/3. If you put footer, 2/3, whoops, hey, come on, 2/3 x to the 1/3 on the bottom. All right, or I might just leave it like this because I'm going to have to put it into, like, take it, some antiderivative action of it anyway. All right, so speaking of the antiderivative, let's throw this into our arc length formula. Definite integral from 0 to 8, I do believe. Yes, okay. Square root of 1 plus our derivative squared. So 2/3 x to the negative 1/3 squared dx. Now, when I square this, that does not make this exponent here positive. It's just 2 times that, right? A power to a power, you multiply the two exponents, but I'll have to square that number also. Up front, 0, 8, square root of 1 plus, it's going to be 4/9 x to the negative 2/3 dx. And so it's definitely at this point that I probably need to bring this down here to the bottom. And then let's see what it is that we can do in order to fix this thing so we can take its antiderivative, 2/3. Okay, so strategies. What if we, let's see what happens if we maybe get a common denominator between these two things. That one is simple enough. I can think of it as a fancy one where it'll be 9x to the 2/3 divided by 9x to the 2/3, right? Of course. So 9x to the 2/3 plus 4 over 9x to the 2/3. All right, did that make it any simpler? Doesn't look like it, but really it does because I can break up these two square roots. I can take the square root of this bottom down here. And since we are, let's say that, of course, is going to be 3, but when I take the square root of this thing, it should still be positive because we're dealing with just positive numbers. So we should be A-OK. So r 0, 8, this is going to be the square root on top, 9x to the 2/3 plus 4, and on the bottom I've got 3x to the 1/3 dx. Is this doable? It looks like if it is doable, I'm going to have to use substitution because we have a composite function here. Got stuff inside of the square root. This seems to be like the thing that we would use for our u. And I know that when I take the derivative of x to the 2/3, I would subtract 1 from it, which would make that x to the negative 1/3, which is the thing that's down here on the bottom. Very, very convenient. Like I said, these things are contrived. Okay, so let's say that our u is equal to 9x to the 2/3 plus 4, our du. Leapfrog that thing down. Let's see, I'd have 18 thirds. Oh, yeah, I guess I could reduce that. Subtract 1, negative 1/3 dx. Let's clean that up. That's just a 6. X to the 1/3, or maybe just 6. That looks like a d. 6 over x to the 1/3 and then dx. Okay, so what I will do then is, first of all, I'm going to bring this 3 outside. Make some room right there. Okay, so let's bring this 3 out. So I'll have this 1/3 on the outside instead. So I'm covered with the, down on the bottom, this x to the 1/3 and the dx. Those things are covered, but I still need a 6 here. So I'll put a 6 in here, and I can do that as long as I compensate with a 1/6 on the outside. Okay, I think we are ready to go. Oh, no, we're not, because I still need to also redo our limits of integration. So u of 8 should be equal to 9, 8 to the 2/3 plus 4. Let's see, take the cube root of that is 2. 2 to the second power is 4. That's going to be a 36 plus 4 is 40. And u of 0 is just going to be 4, because of course that's going to go to 0. All right, now I think that we need another page. These are all 2-page problems. Hope you got room in your notebook. All right, so combining those fractions up front, I've got a 1/18 definite integral now from 4 to 40 of the 6, the x to the negative 1/3 basically, and the dx, all of that's going to become our du. And the square root of 9x to the 2/3 plus 4 is just going to be the square root of u, oops, or, u to the 1/2 power. Okay, take its antiderivative, 1/18. This will be u. Add 1 to that exponent, that's going to be 3/2 times a 2/3. I don't need this dot here. 2/3. Okay. And then cleaning up this fraction here, let's see, that'll be a 9. That's 27th. 1/27th. And then, hey, don't forget your limits, 4 to 40. And now we're ready for our substitution, our FTC, 1/27. Put that on the outside. This is 40 to the 3/2 power minus 4 to the 3/2 power. Yeah. And I would recommend just leaving it like that. This one, you're not going to probably simplify it too much further. This one you could, because you can take the square root of our 4, get 2, 2 to the 3rd is 8. So you could, if you wanted to, rewrite this part as an 8, or maybe it's a multiple choice question, you had to match it up or something. But over here, probably not so much. Okay, well, there we go.